Hello, I'm Olivia Gatea. Today's date is 12/19/25, and my group was number 7, letter G, if that matters. And alright, so the formula I was given was C9H12, and to find the degrees of unsaturation, I found that it was 4, and how you do this is by multiplying the amount of carbons by 2, so 9 times 2, then you always add 2 after that, and then you subtract the hydrogens. We had no other oxygen, nitrogen, anything like that, so it was just 18 plus 2 is 20 minus 12, which is 8, divided by 2, which is 4. So I knew that we had to have, possibly, it could have been a ring plus 3 bonds, so that was a possible, definitely I was thinking about that the whole time, was possibly having a benzene ring, so that was a good clue for what it could be. And then our first spectra was the IR spectra, and starting off with the first group, I want to look at 330, which is right here, and this signals that we have some sp2CHs here, which I deduced would be sp2CH aromatic CHs. So those would be the hydrogens coming off of the benzene ring. So that's what I thought that could be. And then next up is just the basic, like right below 3000, we have sp3CH3s. So this could be CH2, CH3, so I was saying, oh, this could be just a regular alkyl CH group. And then the next group we have is around 1600 or 1500, around right here and there. So this actually signals to us that there are some C-C double bonds. And so that definitely matches up with a possible benzene ring. So you have two things here that might signal us that there is a benzene ring. So, we'll keep that in mind. Next, we have the carbon-13 spectrum. So, with the first group, 125 to 145, it's this one and then these two right here. So, this is signaling to us that there could be some aromatic carbons here, as well as C-C double bonds. So this really helps us move forward in the benzene ring structure idea in our head. And then at this point I was thinking, well, if we have a benzene ring, we need 3 more carbons. So we could just do a simple carbon chain after that. That was a pretty good thought, but we can't confirm that quite yet, in my opinion. So we'll keep that in mind. And then over here we have these 3 other carbons. And so these are all in the range that include just normal sp3 hybridized carbons. So if we follow along with the idea of having a 3 carbon chain at the end of it, well, we have 3 carbons here. So this one could be the benzylic CH2 coming right off of the benzene ring. This one could be an alkyl CH2, which is in the middle of the benzylic one and the terminal one. And then here, 14, terminal CH3, the lowest, or the most upstream. So that checks out for having us with the benzene ring. We have our CH, or aromatic carbons, as well as C-C double bonds, and then just 3 carbons here. So we're going down the right direction here, in my opinion. I already have this drawn out for us, but we have these 4 sections here. The first one we can look at is right here, 7.1, 7.3. This is 5H. So I would immediately thought, oh, these are our aromatic protons. So in this case, it is a mono-substituted benzene ring. So we have 5 equivalent, or 5 equally integrated protons coming off of this benzene ring, but they're not actually equal I got cut off, but I was saying that these protons on the benzene ring are not equivalent, so it doesn't lead to them being just perfect singlets. Even they're multuplets, so that's why we kind of have like this messy peak right here. It would have just been like a nice straight line, but now it has this mess at the bottom. So the next one at 2.6 is a 2H. So we also only have 3 more sections here. So this goes on with our idea, oh, we have a benzene ring plus just a 3-carbon chain. So this is a 2H, meaning it could be a CH2. And then it's far enough downstream where it could be our benzylic CH2. So we have the phenyl and then the CH2. And then it's also a triplet. So that means it only has neighbors from the next CH2 to on its right, which checks out. So then it wouldn't be just like a dimethyl, but on different sides of the ring. The next one's 1.6, another 2H upstream, and this is going to be our alkyl CH2. So we see it's in between a CH2 and the CH3. At 0.9, here we have finally a 3H, meaning this is our terminal CH3, and it is a triplet because it's next to this CH2 right here. And then also this one is a sextet, or like ideally a sextet, but it's a multuplet. This is our alkyl CH2. We can see it has 2 on the left, 3 on the right. Add it all up, you get 6, which is the sextet. But back to 0.9, we have our 3H triplet terminal CH3. So everything checked out, which means we can propose our structure, which is just this benzene ring with a 3-carbon chain. And I'm going to write down the name. It is N-propyl benzene. And that is it. Thank you so much.